Okay, so let's start with ratio. And some of this is super easy and you'll fly through it. And some parts of it are a little bit tricky. So let's start with the very basics, which would be simplifying ratios. So I'm going to start with just whole numbers. So when I'm talking about simplifying ratio, I'm first looking for a common factor, and we've used common factors quite a lot. So if I'm looking at 9 and 15 here, common factor between 9 and 15 is 3. And then I'm looking at dividing both of those numbers by the common factor, and it should be the highest common factor. So 3 goes into 9 3 times, and 3 goes into 15 5 times. Okay, so this ratio simplifies down to 3:5. Okay, now, really importantly, you know you're finished when these numbers can't divide into each other. So there's nothing that will divide into 3 and also divide into 5. Okay, and then you know you're done. The next one is 14:35. So if I'm thinking of my highest common factors, 14 won't go into 35, but 7 will. 7 goes into 14 twice, and 7 goes into 35 5 times. And I'm left with my ratio of 2:5. So highest common factor is what I'm using here, a huge amount. Okay. Right, take a look at this one, 60 cent to €2.40. A little bit different here because I've got cent and euro, and I can't compare ratio unless I'm comparing the same values of things. So cent and euro doesn't work for me. So instead, I either change them both to euro or both to cent. In this case, I'm going to say cent is easier. 60 cent, €2.40. There are 100 cent in a euro, and we should be able to change that to 240 cent. So now I'm looking at 60 to 240. The first thing I know is that 10 goes into them both. So 6 is to 24. Now I'm definitely not quite finished because there's still a number that will go into both 6 and 24. 2 will go into both of them. But also 6 will go into both of them. Okay? And I'm looking for the highest number that will go into both 6 and 24. 6 goes into 6 once and goes into 24 4 times. Okay, so my ratio is 1:4. 5 minutes to 1 hour. Again, I've got minutes and hours. So I need to change them to be the same units. 1 hour is 60 minutes. 5 will go into both of these numbers. 5 goes into 5 once, and 5 goes into 60 12 times. So I'm talking about dividing in. So this is 1:12. Okay, and the last one up here, 0.4 kgs to 500 grams. Okay, again, this doesn't work. I've got kilograms and grams. So there are 1,000 grams in 1 kilogram. So 0.4 will be 400 grams to 500 grams. It's easiest to keep them not in decimals. I could have also said here 0.4 to 0.5 because and kept them in kilograms. So I could have said 0.4 kg to 0.5 kg if I wanted. Okay, but I'm going to try and keep them in whole numbers. Okay, so first of all, I can divide both of them by 100, which will bring it right back down to 4:5. 4 grams is to 5 grams. And then I can't do any more. There's no number other than 1. There's no number that will divide into 4 and also divide into 5 other than 1. But I'm not going to take 1 because 1 into 4 will still give me 4 and 1 into 5 will still give me 5. Okay, going into fractions. So as always, I tend not to particularly like fractions. Okay, so when I'm dealing with fractions, I can't compare two different denominators. Okay, so I either need to completely remove the fraction or compare them under the same denominator. Okay, so two options. Okay, if I want to remove the fraction, okay, I have 5 over 2 is to 5 over 4. I'm going to look at the lowest common multiple of the denominator, okay, which is 2 and 4. The lowest common multiple is 4. And I'll multiply this side by 4 and this side by 4. And 2 goes into 4 twice, 4 goes into 4 4 times, so it'll cancel. 2 times 5 will be 10 is to 5. And then once I have them into whole numbers, I have to then simplify. So then 5 goes into 5 once and 5 goes into 10 twice. So this will actually simplify down to 2 is to 1. Now alternatively, I can compare them with just a common denominator. So 5 over 2 is to 5 over 4. Okay. And here I have 5 is to 2 over 5 is to 4. Well, to get 2 to be a denominator of 4, I'd have to multiply it by 2. And what I do to the bottom line, I do to the top. Okay? And once I get them the same denominator, once the denominators are the same, I can only compare the numerator, which leaves me with 10 is to 5, which is the same 2 is to 1. This one certainly is my preferred or preferable one, is removing the fractions from word go. But you can use the denominator as well. Right, this time we have 4 is to 5 over 8. So 4 is a whole number and 5 over 8 is a fraction. So I'm going to change this to 4 over 1 is to 5 over 8. Okay, and again, I'm going to stick with my first method, which is to get rid of the denominator. So the lowest common multiple here between the denominators is 8. So multiply both sides by 8. 1 goes into 8 times. So similar to removing fractions. And I get 32 is to 5. And there's actually no number that will go into both 32 and 5. So I'm done. The last one then is a mixed fraction and then a decimal. Okay, so I don't particularly like either one of these. I need to change them into regular fractions. So 3.5, I want to change my mixed number into a regular fraction. So I take my whole number, I multiply it by the denominator. So 3 times 2 is 6. And then I add in the 1. So that should be 7 over 2. I'm just going to leave my 1.4 here for a second. Is to 1.4. Okay. And I want to change this 1.4 into a fraction. Okay. So 1.4 is 1 and 0.4 effectively. So 0.4 we should know is the fraction 2 fifths. So 1 and 2 fifths. So again, multiply the number by the denominator. 1 times 5 is 5. Add in your top line, and we should be able to do that going back to first year and to primary school fractions. So now I've got 7 over 2 is to 7 over 5. I want to get rid of my bottom line, get rid of my fraction now. So my lowest common multiple of my denominator this time, between 2 and 5, is 10. So multiply both sides by 10. 2 goes into 10 5 times. 5 goes into 10 twice. 5 by 7 is 35. 7 by 2 is 14. And once I'm left with a whole number, then I can look at simplifying. And I'm looking at the highest common factor of 35 and 14, which is 7. So divide 7 into 14, goes twice. Divide 7 into 35, goes 5 times. And I'm left with from 3.5 to 1.4, gets me 5 is to 2. Okay, moving on to a word problem. 6 students in a class of 32 are absent. find the ratio of the number of absent to the number present. So if 6 students are absent, that is going to be 6 is to 32 in the class. So if there's 6 absent, there must be 26 present. Okay. And if there is 6 to 26, I still need to simplify this ratio. So what goes into both 6 and 26? So 6 won't go into 26. 3 won't go into 26. So I'm looking at 2 going into both of them. So simplifying it down to 3. So 2 goes into 6 3 times. And 2 goes into 26 13 times. So left with 3 is to 13. The number absent to the total number of students in the class. Okay, I'll just do this one out here. The number absent is 6 to the total number in the class, which was 32. So 6 is to 32. 2 will go into 6 again 3 times. 2 will go into 32 16 times. And there's no number that will go into both 3 and 16 other than 1. The number present, which we said from part A, was 26. If there are 6 students absent, there must be 26 present. To the total number in the class, which is 32. And I'm left with 26 is 32. Well, first of all, I know they're both even numbers. So the easiest number to divide in is going to be 2. 2 into 26 goes 13. 2 into 32 is 16. And because 13 is a prime number, there's definitely no number here that will divide into both 13 and 16. So my final answer there is 13 to 16. Okay, dividing an amount into a given ratio. So these are nice and easy. When I think of ratio, I'm thinking of parts. Okay, that's all ratio is. Okay, is parts. Okay, so I'm dividing €20 between Patrick and Sarah in the ratio 4:3. So if it's a ratio of 4:3, that means there are 7 parts. Okay, 7 total parts. 4 of those parts go to Patrick and 3 of those parts go to Sarah. So if I want to divide in a given ratio, I need the total parts first, okay, which is the sum of the ratio. So I take €20 and I'm going to divide it by 7. Okay, now that gives me a fraction. So on your calculator, just leave it as 20/7. Patrick gets 4 parts. So Patrick gets the 20/7 times 4, and it wants to the nearest cent. So Patrick should get €11.43. Sarah, because remember, and I should have said this is 1 part. So when I divide by the total parts, that gives me what 1 part is. So 20/7 is equivalent to 1 part. So I multiply it by 4 to get Patrick's. And then to get Sarah's, I take my 1 part. And again, I multiply it by 3. And I will get €8.57. Okay. This one, slightly different. A total area of a site is 575 metres squared. Anne is building a house on the site. The given ratio of the house area to garden area is 5:8. So again, 5:8, that means I have 13 total parts. Okay, of the 13 total parts, the house area gets 5 of those parts, and the garden area gets 8 of those parts. Okay, now the total amount of parts has to equate to the total amount of areas. So 575, that's split into 13 parts. Okay, so 575 divided by 13 is going to give me And again, I get a fraction here. Okay. So I'm actually going to leave it as, on my calculator, 575 over 13. Okay. And if you do that on your calculator, that's how it will come out. I want to find the area of the garden only. So remembering that this is one part. Okay. So when I divide by the total parts, that gets me one part. And I need 8 of them for the garden. So 8 of them for the garden, and I'm going to give it to the nearest metre squared here, which is 354 metres squared. Okay, so that's rounded to the nearest metre squared. Okay, so when you're splitting or dividing into a ratio, you need to find the total number of parts first, divide the area or divide the total by the total number of parts. That gets you one part, and then multiply by what you're looking for. So last example on this, almost last example on this. Julianne and Kevin inherit 5,500. Julianne is 24 and Kevin is 9. The money is to be divided in the ratio of their ages. How much will each receive? So 24 is to 9. Now, I can use 24 and 9 and I can split it with 35. But I can actually simplify this because 3 will go into both. 3 will go into 9 3 times, and 3 goes into 24 8 times. So I can simplify this ratio if I want first down to 8 and 3. So that gives me a total of 11 parts. Okay, because ratio can be simplified all of the time. I can always use simplified ratios as long as I'm dividing both sides of the ratio by the same number. So I take my 5,500 and I'm going to divide it by my total 11 parts. So 5,500 divided by 11 will give me 500, which is one part, remember. So when I divide by the total, that gets me one part. Once I have one part, I know Julianne, who was the 24, she's getting the 8 parts. And Kevin, who's the younger one, is getting the 3 parts. So 500 by 8 for Julianne, which is 4,000 for Julianne. And Kevin gets 500 by 3. So Kevin gets 1,500 goes to Kevin. Okay, almost there now. In a 1,000 milliliter mixture of fruit concentrate and water, there is 40 ml of fruit concentrate. What is the ratio of the amount of fruit concentrate to the amount of water? So there's 1,000 milliliters in the entire mixture. Okay, if there's 40 ml of the fruit concentrate, then there must be 1,000 minus the 40. There must be only 960 milliliters of water. Okay, because this is the total, and if there's 40 ml of the fruit concentrate, then the rest must be water, because there's 1,000 has to be the total number of parts. And I'm going to simplify this. So first of all, they'll both divide by 10. So 4 is to 96. And just check, 96 divided by 4, it goes in evenly. 4 goes into 4 once, and 4 goes into 96 24 times. Okay, so the simplified ratio is 1 is to 24. If 200 ml of concentrate is added to a mixture, what is the ratio of the amount of fruit concentrate to the total volume of mixture? Okay, so 200 is added, okay, and it's the fruit concentrate that's added. So now I don't change the amount of water. I still have the amount of, I'm just trying to see which comes first. What is the ratio of the amount of fruit concentrate to the total volume of mixture? So sorry, the total amount of fruit concentrate now was 40. I've now added 200 more. So I now have 240 ml of the concentrate. So I originally had 40. I'm adding in 200 to the total volume of the mixture. So remember, I had 1,000. If I've added in 200, I now have 1,200 millilitres. Both can be divided by 10. So 24 to 120. 12 will go into both of these numbers. 12 goes into 20 twice. So 12 goes into 24 twice. 12 goes into 120 10 times. And I'm left with 2 to 10. Now, 2 to 10 still has a common factor. 2 goes into 2 once. And 2 goes into 10 5 times. So for question B, it's 1:5. And finally, for question C, what's the ratio of concentrate to water? So now the water never changed. I never added in any more water. I have, for part C, I have 240 millilitres of the concentrate because I started with 40. I added 200 more of the concentrate in. I never added any more water, so I'm left with 960 millilitres of water. That never changed. So that is the fruit concentrate to water. And always try and do your ratios in the same order as they're written. First of all, I can divide them both by 10 because they end in 0. So 24 to 96. And I can drop the units. You've probably noticed that I've done that because my ratio doesn't need to include the units then. Let's see, does 24, so 96 divided by 24. So it does actually go in. So 24 actually will go into 96 here. So 24 goes into 24 once. And if I divide 96 by 24, I'll get 4. So the ratio of fruit juice to concentrate in the new mixture is 1:4. All right. Last part of this is when you know part of the ratio, and there's only 2 questions left. If a sum of money is divided amongst Amy and Ben in the ratio 3:5. So again, 3:5, that means that there are 8 parts. Okay, 3 of those parts belong to Amy and 5 of those parts belong to Ben. Amy receives 120. So that must mean that the 120 is equivalent to 3 parts. Okay, I want to know what Ben receives. So I want to know what's 5 parts. Okay, now in any type of maths and converting from one type or from one number to another, the easiest number to always go back to is 1. Okay, so I know that 120 is 3 parts. I want to get what 1 part is. Now, to get from 3 to 1, I divide by 3. And so I have to do the very same to 120. So 120 divided by 3 gets me 40. So €40 is 1 part. So if Ben receives 5 of that, then Ben takes the €40 and multiplies it by 5. Okay, and that will get him 5 parts. So Ben receives, €200, which is 5 parts. And how much money was there to divide out in the beginning? Well, at the beginning there had to have been 8 parts to divide it into 3 and 5. So again, if I want 8 parts, as long as I know what 1 part is, and that's like my golden number, knowing what 1 part is. Once I know what 1 part is, 40 times 8, and that will give me 320 €320. Okay, finally, at a concert there are 15,000 girls. The ratio of girls to boys at the concert is 5:2. So the 15,000, that's only 5 parts because that's only the girls. And girls to boys is 5:2. Find the total attendance. Well, the total attendance is the total ratio, so 7 parts. And if I know that 5 parts are equal to 15,000, then I can get that 1 part is equal to 15,000 divided by 5, which is, we're not talking money here, apologies, which is 3,000. And once I have what 1 part is, I can find the total amount of parts. So 7 parts, which is the total attendance, is 3,000 times 7. So 3,000 was 1 part, times 7 gets me 21,000 people at the concert. Okay, in which 15,000 were girls, and then there must only be 6,000 then that were boys. Okay, so important thing to note when dealing with ratio is ratio deals with parts. That's all it is. Okay, is splitting things up into parts. And actually probably the most important example was this one here, up here about, my thing is, was, where am I gone? Splitting the fruit juice. Nope, back down. Okay, with splitting the fruit juice, because when you add things into a mixture, or when you add things in, the ratio has to change, because the ratio here was specific to A. Once something was added in, it's then changed. Okay, so you have the ratio of the fruit juice to water here was 1:24. If I was to look at the ratio of the fruit juice to water at the very end, I actually get 1:4. So very, very different. So be careful when you're talking about ratio and you're talking about adding different parts in. That does affect the ratio, and make sure you understand what you're adding in. So how many parts did I begin with, and how many parts am I adding in as I go? Okay, so biggest thing you need to remember is ratio is all about parts.